The National Electrical Code, or NEC, does not specifically prohibit the use of number 12 wire as a support for electrical conduit. However, it does state that the methods of support must be approved by the authority having jurisdiction, often referred to as the AHJ, and must be adequate to prevent damage to the conduit or its contents. NEC Article 358.12 states conduit shall be securely fastened in place at intervals no greater than 12 feet, which is approximately 3.65 meters for rigid metal conduit, 10 feet, or approximately 3.5 meters for intermediate metal conduit, and 8 feet, or approximately 2.44 meters for rigid non-metallic conduit. NEC Article 358.30 states conduit shall be supported by approved means from its first point of suspension to within 3 feet, or approximately 0.91 meters, of its termination and at each outlet box, junction box, cabinet, or fitting. While number 12 wire may not be specifically prohibited by the NEC, it is generally not considered an approved support method by most AHJ. AHJ typically required the use of caddy clamps, threaded rod, or other approved methods of support. There are several reasons for using approved support methods. Firstly, number 12 wire is not as strong as other support methods and may not be able to withstand the weight of the conduit and its contents. Secondly, number 12 wire can become damaged or weakened over time, which could lead to the conduit becoming unsupported. Thirdly, using unapproved support methods can void warranties from conduit manufacturers. Therefore, it's important to understand the NEC guidelines and the AHJ requirements for proper conduit support. The NEC sets the standard for safe electrical installations, and while it provides specific requirements for support intervals, the method of support is subject to the AHJ approval. This flexibility allows the AHJ to consider local conditions and ensure that the chosen support method is adequate for the specific installation. Approved support methods, such as caddy clamps and threaded rods, are designed and tested to provide reliable support for conduits. They are typically made of durable materials that can withstand the weight of the conduit and its contents, as well as environmental factors such as temperature changes and corrosion. These supports also provide a secure and stable connection that prevents the conduit from moving or shifting over time. In contrast, number 12 wire may not be able to provide the same level of support and stability. It is not as strong as other support methods and may be more susceptible to damage or weakening over time. Additionally, number 12 wire may not provide a secure connection, which could allow the conduit to move or shift, potentially causing damage to the wiring or creating a safety hazard. The weight of the conduit is a critical factor. Conduits, especially when filled with wires, can be quite heavy. Number 12 wire might not have the tensile strength to continuously bear that weight, leading to sagging or even breakage. Environmental factors also play a role. Temperature fluctuations can cause expansion and contraction of the conduit, putting stress on the support. Wire might stretch or weaken under these conditions. Corrosion is another concern, especially in damp or corrosive environments. Wire can corrode over time, further reducing its strength and reliability. The importance of consulting with the AHJ cannot be overstated. They have the authority to interpret the NEC and make decisions about what is acceptable in their jurisdiction. They can provide guidance on approved support methods and ensure that the installation meets all applicable safety requirements. Furthermore, the AHJ can provide valuable insights into local conditions and potential hazards that may affect the choice of support method. They may also be aware of specific requirements or best practices that are not explicitly stated in the NEC. Warranty considerations are also crucial. Using unapproved support methods can void the manufacturer's warranty on the conduit. This means that if the conduit fails or is damaged due to improper support, the manufacturer will not be responsible for the cost of repair or replacement. Therefore, it is important to use only approved support methods to ensure that the warranty remains valid. In summary, while the NEC does not explicitly prohibit the use of number 12 wire as a support for electrical conduit, it is generally not considered an approved method by most AHJ. Approved support methods, such as caddy clamps and threaded rods, are designed and tested to provide reliable support and stability. Using unapproved support methods can lead to safety hazards, void warranties, and potentially damage the conduit or its contents. Therefore, it is essential to consult with the AHJ and use only approved support methods to ensure a safe and compliant electrical installation. Consider, for example, a scenario where a long run of rigid metal conduit, RMC, is installed using number 12 wire as the primary support. Over time, the weight of the conduit, combined with temperature fluctuations and potential corrosion, could cause the wire to stretch or weaken. This could lead to the conduit sagging, putting stress on the connections and potentially causing the wires inside to become damaged. In a worst-case scenario, the conduit could even break free from the supports, creating a significant safety hazard. Now, consider the same scenario with approved caddy clamps. These clamps are designed to securely grip the conduit and distribute the weight evenly. They are made of durable materials that can withstand the weight of the conduit and the effects of temperature and corrosion. The clamps also provide a stable and secure connection that prevents the conduit from moving or shifting. As a result, the conduit remains securely supported even under adverse conditions. Furthermore, approved support methods often include features that make installation easier and more efficient. For example, some caddy clamps are designed to be installed with a single screw, which can save time and effort compared to using multiple wraps of wire. Other support methods include adjustable features that allow for fine-tuning of the conduit's position. Always ensure the supports are correctly sized for the conduit you are using. Using undersized supports can compromise their ability to bear the load safely. The spacing requirements outlined in the NEC are also critical. Exceeding the maximum spacing between supports can lead to sagging and potential stress on the conduit and its connections. These spacing requirements are designed to ensure that the conduit is adequately supported along its entire length. Furthermore, consider the type of environment where the conduit is being installed. In corrosive environments such as near saltwater or industrial facilities, it is important to use supports that are made of corrosion-resistant materials. Stainless steel or galvanized supports are often used in these applications to prevent corrosion and ensure the long-term reliability of the installation. In addition to the physical supports, it is also important to consider the method of attachment. Support should be securely fastened to the building structure using appropriate hardware. For example, when attaching supports to concrete, it is important to use concrete anchors that are designed to withstand the weight of the conduit and the pull-out forces that may be exerted on the supports. Likewise, when attaching supports to steel beams, it is important to use beam clamps or other hardware that is specifically designed for this purpose. The selection of appropriate hardware is critical to ensuring that the supports are securely attached and that the conduit is adequately supported. Another important consideration is the potential for vibration. In environments where there is significant vibration, such as near machinery or equipment, it is important to use supports that are designed to dampen vibration and prevent it from being transmitted to the conduit. Vibration can cause the conduit to loosen or fatigue over time, which can lead to failure. Using vibration dampening supports can help to mitigate these risks and ensure the long-term reliability of the installation. Regular inspections are also essential. Electrical installations should be periodically inspected to ensure that the supports are still in good condition and that the conduit is properly supported. Inspections can help to identify potential problems before they become serious and allow for timely repairs or replacements to be made. During inspections, it is important to check for signs of corrosion, damage, or loosening of the supports. It is also important to verify that the conduit is still properly aligned and that there are no signs of sagging or stress. Any problems that are identified should be addressed promptly to prevent further damage or safety hazards. Proper documentation is also important. Detailed records should be kept of all electrical installations, including the type of supports used, the spacing between supports, and the method of attachment. This documentation can be valuable for future maintenance and inspections. It can also be helpful in resolving any disputes or questions that may arise regarding the installation. In addition to the NEC and the AHJ requirements, there may be other applicable standards or regulations that must be followed. For example, some local jurisdictions may have specific requirements for the type of supports that can be used in certain types of buildings or environments. It is important to be aware of all applicable requirements and to ensure that the installation complies with all relevant standards. Training and education are also essential. Electricians and other electrical workers should be properly trained and educated on the proper methods of supporting electrical conduit. Training should cover the NEC requirements, the AHJ requirements, and the best practices for selecting and installing supports. Proper training can help to ensure that electrical installations are performed safely and correctly. The use of number 12 wire as a conduit support may seem like a simple and cost-effective solution, but it is important to consider the potential risks and consequences. Using unapproved support methods can compromise the safety and reliability of the electrical installation and potentially lead to serious accidents or property damage. Therefore, it is always best to err on the side of caution and use only approved support methods that are designed and tested to provide reliable support. Remember that electrical codes and regulations are in place to protect people and property. By following these codes and regulations, and by using approved support methods, you can help to ensure that electrical installations are safe and reliable. Always prioritize safety and compliance when working with electricity. Furthermore, technological advancements continue to influence electrical installation practices. New types of conduit supports are constantly being developed, offering improved performance, ease of installation, and cost-effectiveness. Staying informed about these advancements can help electricians and contractors make informed decisions about the best support methods for their specific project. For instance, some manufacturers offer innovative support systems that utilize modular components, allowing for greater flexibility and customization. These systems can be easily adapted to accommodate different conduit sizes, configurations, and mounting conditions. They can also simplify the installation process, reducing labor costs and improving overall efficiency. Additionally, advancements in material science have led to the development of lighter and stronger support materials. These materials can provide the same level of support as traditional materials but with a reduced weight, making them easier to handle and install. They can also offer improved corrosion resistance, extending the lifespan of the support system. Building Information Modeling, or BIM, is also playing an increasingly important role in electrical design and installation. BIM allows for the creation of a digital representation of a building, including all of its electrical systems. This can help to identify potential conflicts or issues before construction begins, reducing the risk of errors and rework. BIM can also be used to optimize the placement of conduit supports, ensuring that they are properly located in space to provide adequate support. Moreover, wireless sensor technology is being used to monitor the condition of electrical conduit and supports. These sensors can detect changes in temperature, vibration, or strain, providing early warning of potential problems. This allows for proactive maintenance and repairs, preventing failures and extending the lifespan of the electrical installation. As technology continues to evolve, it is important for electrical professionals to stay up to date on the latest advancements and best practices. By embracing new technologies and techniques, they can improve the safety, reliability, and efficiency of electrical installations. In addition to the technical aspects of conduit support, it is also important to consider the aesthetic aspects. In some cases, exposed conduit may be visible to the public, and it is important to ensure that the supports are aesthetically pleasing. There are a variety of support options available that are designed to be both functional and visually appealing. For example, some supports are available in a variety of colors and finishes to match the surrounding decor. Others are designed to be concealed within the building structure, minimizing their visual impact. When selecting conduit supports, it is important to consider the overall aesthetic of the space and choose supports that complement the design. Collaboration between architects, engineers, and electrical contractors is essential to ensure that the electrical installation is both safe and visually appealing. In conclusion, the proper support of electrical conduit is a critical aspect of electrical safety and reliability. While the NEC provides general guidelines for support intervals, The AHA has the final say on the acceptable methods of support. Using approved support methods, such as caddy clamps and threaded rods, is essential to ensure that the conduit is securely supported and that the electrical installation meets all applicable safety requirements. Staying informed about the latest technologies and best practices is also important to ensure that electrical installations are performed safely, efficiently, and aesthetically pleasing. By prioritizing safety, compliance, and innovation, electrical professionals can help to create safe and reliable electrical systems that meet the needs of building occupants and protect property from damage. Always remember to consult with the AHA and follow all applicable codes and regulations to ensure a safe and compliant electrical installation.